Hello there. I like YouTube videos and I like to kind of recreate things that I see. So in this latest video, let me just show you really quick. Let's see if I can pull this up. This is Destin from Smarter Every Day. You have to go watch his series on submarines. It's really the best. And so let me just show you a part of it where he talks about sonar. And in this sonar video, he looks at this bearing rate graph. Where'd it go? Right here. So he has a guy explain to him this thing that you'll see in the submarine, a bearing rate graph, and so he goes through that. And you should see it. His explanation is fine. And I have over here, this is the hunt. I think this is the same thing. This is the hunt for Red October, and they are, spoiler alert, they're chasing a Russian sub, and you can see here this graph right there. I think that's the same thing as bearing rate graph. Okay, so let's make this, because you can't really understand something unless you can make it. And so here is the way that I'm going to do this. I want to take a submarine and a boat and have them move and produce my own bearing rate graph. I'm going to do this in Python. I'm going to use the GlowScript v Python so I can actually do two things. I can model the motion of these two things in 3D and produce the graph. So you can see the relationship of how they are in real life, or not real life, in the thing, and then make the graph. Now, I haven't done this yet, so this may not work. We're doing this together. We're working it out. Let's just see what happens. So imagine that I have these two objects. Here's my sub and a boat, or a contact. I don't really know. I'm not in the Navy, so I'm just going to use sub and boat. And if those are offensive terms, I apologize. Again, I don't know what I'm doing. I just know physics and I know Python. And I'm not even that great at Python, to tell you the truth. So I can make these two things move. I'll make these as 3D objects, and I'm not going to go into all the details of that, but we'll work it through, and you can see that. And then so once I'll make this like a cylinder and that like a rectangle, and they'll move. So they both have a velocity. And I'm going to pick V sub with a velocity of 10 meters per second, which is about, like 20 knots or something like that. And I know they use knots. I do know that. Okay. And let's use the boat. The boat's going a little bit slower. V boat is 5 meters per second. And then I need to pick real bearings for these, right? Because I want the bearing relative to the position of the sub, not the actual bearing of the two objects. So let's say that this is going, just like I said, let's call this theta sub, and let's call this theta boat. So theta boat is going to be equal to negative, I'll use degrees, 20. And theta sub is going to be equal to, 40 degrees. And then I'll put the distance between these two at some value. Let's just pick that once we start making those things. But there we have some numbers. Okay. So how do I get the angle, this angle theta, from not just the position of the boat relative to the direction the sub is moving? So we're going to need to use some vectors here. Vectors. So if you haven't used vectors, then we may have some trouble. But in short, a vector is a way to represent, it's a variable with more than one dimension. So let's just go ahead and represent a velocity vector. So let's say v sub as a vector. We put the arrow over a variable to indicate that it's not one-dimensional scalar. It's more than that. I'm going to write this as the following. Let's say it's 5, 2, 0, and meters per second. So this says moving 5 meters per second in the x direction, 2 meters per second in the y direction, and 0 in the z. Now, actually, now that I'm thinking about it, the default coordinate system for VPython, for GlowScript, is to have this is x, this is y. Okay, that's fine. That's y. That'll work. So I'm going to first need to get these values, these x and y components, from the magnitude of the velocity and the angle. So let's just redraw this. So let's say here's my angle theta s, and here is vs. It's the velocity vector of the sub, and here's theta s. Well, the y component right here and the x component right there make a right triangle. So if the magnitude of this is 10 and that angle is 40, then this, if I take the sine of 40, sine is opposite over hypotenuse, that's going to be equal to Vx over V sub. The cosine of the angle 40 is going to be the adjacent, which in this case is the y direction, Vy over V sub. So I can find Vx is V sub sine 40. And because I'm measuring from because of the way I'm measuring the angle. And then Vy is going to be Vs cosine 40. And so I can get my values for x and y. I could do the same thing for the boat. All I need to know is its bearing and its direction. So this is for the sub. And then for the boat, Vx equals V boat. And in fact, this one's going to be negative, because if you look over here, my boat's going in the negative x direction, but I said that as a positive. No, I did. I give it a negative angle. So with this, let's see. So that's going to be V sine of negative 20. I think that'll work. And then Vy is going to be Vb cosine negative 20. I think those values will work, but we can check them. So that's for the boat. Okay, but we still don't know how. I'm shaking my camera, I'm sorry. We still don't know how to get this angle theta. Okay, so we actually need one other vector. I want to find the angle between this velocity of the, actually I don't really need that. I need the velocity of the sub and this vector, which is a position vector. I'm going to call it r. And I want to find the angle between those two vectors. Okay, so there's two things that we need to cover. Finding r, the vector, and then angle between r and v sub. That's what I want. Okay, so let's find, these are the two things I'm going to cover, and then we're going to jump over to the computer, and we're going to have a great time. It's going to be great. I'm going to have a great time. Okay, so let's redraw our two objects. Here's the submarine. I'll just draw it as a triangle. And then here's the boat. I'll draw it like that. And I have actually two things, right? Let's say this is my x and y axis. I have over here, I'm going to call this RS. This is the vector position of the sub. This is the location of the sub with respect to the axis as a vector. And then I have another vector. I picked my coordinate system poorly right there. R boat. This is the location of the boat with respect to some arbitrary axis of the origin. If I want to find this vector from R sub to RB, I'm going to call that R. That's going to be the difference between these two vectors. It's going to be R is going to be equal to R boat minus R sub. And so if you think about this in terms of vector addition, it might make a little bit more sense. If I take the negative R sub as this vector, and I add it to this vector, R boat, it goes down here, and then the resultant is this. Well, my things didn't turn out perfectly, but it's the same as that. Okay, so if you want to go from the end of the sub to the end of the boat, you do a subtraction like that. And that's how I can find the vector position. And I need that because I want to find out, let me redraw my sub. Here's my sub. Here's its velocity vector v, and then here is the bearing vector, which is just called r. Now, how do I find the angle between those two vectors? This is where an operation called the dot product comes in, also known as a scalar product. Scalar product. So it's an operation between two vectors. If I have vector A, and I'll just define this as AX, AY, AZ, it can be any vector. It has X, Y, Z components. And then I have a vector B, and it's BX. And this is how I write my vectors. There's my X component, Y component, Z component. I hope that makes sense. This is the same way we do it in Python, so that's just an added bonus. BY, BZ. Well, of course, I could do A plus B, and that would be the vector AX plus BX, AY plus BY, AZ plus BZ. That's like that. So that's just vector addition. And you could do vector subtraction too. So we define the dot product as the vector A dot vector B, and we use a little dot. It looks like a times, but it's actually a dot. It's going to be equal to the product of AX and BX, AX times BX, plus the product of the Y's, AY times BY, plus AZ times BZ. And you'll notice that AX, AY, and AZ are all scalar values. And so that means that this is a scalar, that's a scalar, and that's a scalar. And I add all these up, I get a scalar value. And that's why this is called the scalar product. And we use this for things like calculating the work done by a force. In physics, that's what you'll see it as, the calculating the work done by a force. Now, there's another way to calculate the scalar product, the dot product. I can say A dot B is equal to the magnitude of A times the magnitude of B times cosine of theta, where theta is the angle between those two. And this is a really useful way to do it. And now, okay, well, what's a magnitude? Well, if I have that same vector A, then the magnitude of A is equal to the square root of AX squared plus AY squared plus AZ squared. So if you think about a vector as being the vector velocity, the magnitude would be how fast it's going, not the direction, just how fast total. But here's the deal. If I set this equal to that, then I can use that to calculate cosine theta. So let me put it right here. So cosine theta is going to be equal to A dot B, which I can do, divided by the magnitude of A, the magnitude of B. And then I can take the inverse cosine to find the angle. And that's how I find the angle between the velocity vector and the position vector. Okay, so let's map out what we're going to do, and then we'll switch over to Python. So I'm going to start off with my sub with the velocity and my boat with the velocity. And they both have a position. And the first thing I'm going to do is just make these things move. Okay, so in order to do that, I'm going to break the program up into tiny time steps. And I'll say R sub is equal to 2 is equal to R sub 1 plus V sub delta t. So this will tell me if I have the position of the sub after some short amount of time, I can use the velocity vector of the sub and find out where it is going to be at a new time. So each time step, I'm going to use this to update the position of the sub. And then I can do the same thing for the boat. R boat 2, and this is 2 means at the end of the time interval, equals R boat 1 plus R boat, V boat delta t. I was thinking of the next step. So that's just how I make these things move. And I'm going to do that first. And then the next thing I'm going to do is to calculate R. R equals RB minus R sub. And then I'm going to calculate the dot product V sub dot R, which I can do in Python. There's a built-in way to do that. I could do it manually too. And then I'll find theta. And then I'll plot it. That's what we're going to do. Okay, switching over to Python. Hopefully this still works. Okay, hopefully you can hear me too. So here I have, this is This is GlowScript vPython. It's not actually Python. It's a lot like it. There's a couple things that are different. I'm actually using trinket.io just because it shows the output right here. So the first thing I'm going to do is make my sub. So let's say sub equals a cylinder. Now, the cylinder is a built-in object in Python. Let me just run this so you can see what that looks like. See? And so there's a cylinder, and I have a 3D object in Python. That's pretty cool. Okay, now the properties I can give this, the first is the position vector. So I'm going to say, where is this at? Let's say, I'm trying to think of some good values. Let's put it at vector. A kilometer would be, let's say, 1,000 meters. I'm going to say 500, negative 600, 0. I could do Z and do, that'd actually be fun, but I'll leave that as a homework project for you. You could do Z being the depth of the sub, but I'll leave that alone. And I'm going to give it, the next thing I need to do is I need the radius of the sub. How wide is that cylinder? What's the radius of that cylinder? Let's say, I'm just guessing here. Let's go 8 meters. It might be too small. And then I'm going to do the axis is the vector from the beginning of the sub, from the position to the end of the sub. So let's have this at some angle. Actually, let's do up here. Theta S equals, what did I say it was? 40. So this is going to be equal to the length of the sub. So it's going to be equal to the length of the sub, which, I don't know, 50 meters. Might be too small. I'm just really guessing here. Times the vector. I'm going to use the same thing that I did before for the velocity. But now I'm using the length. So it's going to be sine. Oh, I need this in times pi divided by 180. Now it's in radians. The default is radians in here. So theta S cosine theta S 0. And I think that's it. No, I made an error. Theta ds. See, you can't. Theta S. Okay, there's my sub right down there. Actually, I want to put it over here. So let's move this to negative 500. Okay, now I'm going to make my boat. It's a rectangle. So it's a box. And its position is going to be equal to, I want it in the upper right hand corner. So let's say vector, let's put it at 700, 0, 0. And now I need, for a box, I need its size. So it's going to be a vector, the length, width, and height. Let's say it is the length. Oh, this is going to make it, it's going to be in the wrong direction, and I'm just okay with that. So let's just make it square. Let's make it 50 by 50 by 50. So 50, 50, and then 3, 5, because that's the thickness of it. Okay. Do I have that? Yeah, there's my box. Okay, one other thing I need to add in here. Make trail equals true. Make trail equals true. So what this will do is it'll leave a little trail marker behind it. Okay. Now I need the velocity. So I'm going to say sub.v, that's the velocity of the sub. It's going to be v sub times vector. What did I say? Oh, it was sine of theta s cosine of theta s. Sine and cosine are built into GlowScript vPython, just so you know. 0. And the boat.v equals vboat times the same thing. Vector, oh, I needed to convert this. I don't have vboat. Theta b equals negative 20 times pi divided by 180. So it's going to be sine theta b cosine theta b 0. Now I need time and my time step. Let's make this something kind of large. Let's say 5 seconds. Okay, now I'm just going to run the whole thing for, I don't know, 200 seconds. So I'm going to say while t is less than 200. Now the next thing, this rate statement right here, this just says how fast do I want, how many calculations do I want per second in real time. Let's just put this at 10. Actually, one loop. No, 10. Let's do 10. One loop. If it's too fast, we can change it. One that says do this 10 times per actual second. Now I need to update the position of the sub. Sub.pos equals sub.pos plus sub.v times dt. So up here, this sub.pos is this vector location of the sub. It actually is rs. Okay, and so right here, what I'm doing is I'm taking rs, I'm adding this v sub times dt, and I'm making it the new sub.pos. This actually moves the sub. And let's do the same thing for the boat. Boat.pos equals boat.pos plus boat.v times dt. Sometimes you just kind of lose it for a second. Okay, let's save it and run it. I'm pretty happy with that. 200 seems a little bit long. Let's just do this for 100 seconds. Okay. Oh, you know what? It keep going forever. That's why. Because t equals t plus dt. I never updated t. Now it stops. Okay, that's good. That's exactly what I want. Let's save it. So I'm saying run it until t is greater than 100, but I never changed t. Okay, so that was my mistake. Okay, so we have our two things. We could change the colors of these. Let's actually do that. Let's make the sub yellow just for fun. Color equals color dot yellow, comma, and over here I'll put the boat as color equals color dot cyan. If you wanted to, you could even make the background blue and everything. You can make it look pretty, but I'm not really concerned. Okay, I'm pretty happy with that. Okay, now we need to make our graph. So to make a graph, I'll include a link down below for my graphing tutorial. But the first thing I'm going to do is say, make an object that's a type graph. And in that, I can give it a bunch of parameters. Now remember, in the bearing rate graph, I want the bearing on the top from, let's say, negative 180 to positive 180. Let's just do negative. Yeah, let's do that. Okay, so I'm going to go ahead and give it some title. So my x title on the graph is going to be equal to bearing in degrees. I'll change it to degrees. And the y title is going to be time. Remember, we want a downward, and this is in seconds, but it probably should be in minutes or something like that. Now, another thing that I'm going to do is to, I'll add this in later, but I want to set, I want to set the axis, x-axis from negative 180 to 80. So I can say x min is negative 180, x max equals 180. So that will set the scale and it won't auto scale. Okay, now I need to add an actual curve. So I will name this is called F1. And it's a type of object, G curve, and the color is blue. If I wanted to plot multiple objects on my thing, I could give them all different names and stuff like that. Okay, so that's all I need for a graph. I need those two things, and down here I'll say F1.plot, and then my x value on that is going to be the bearing. This is called, I guess we can call it bearing. And then the y is going to be, I'm going to put it as negative t, so it'll draw it going down. But I haven't calculated bearing yet. So the first thing I need to do here, like I said, okay, is to calculate that vector r. So r is equal to the boat position, boat.pos, minus sub.pos. And you can do that, right? I can do this vector subtraction in Python. It knows how to do that. It knows how to handle vectors. The next thing I need to do is take the dot product. So let's call this b dot. And I could do this all in one step. Let's do it all in one step. So bearing equals, it's going to be the dot product. So there's a built-in function dot product, and it's going to be sub.v r. And then I need to divide that by, I'm skipping a step here. Divide that by the magnitude of sub.v times the magnitude of r. So mag is a built-in function in Python that returns the magnitude of a variable. Now, that's not all I need to do. I need to take the inverse cosine of that whole thing. So I'm going to put that in parentheses and say a cos. Then that will give me the angle in radians. I want to convert that to degrees. So in degrees, I want to convert degrees, say times 180 divided by pi. And that's my bearing. I think that works. I'm just going to run it. I think it might work, but let's save it. You know I make mistakes all the time. And I will give you this code. Okay. So there we go. That worked. Let's run that again so you can see this. I'll scroll it down quicker. Oops. Okay, so there we go. Now, I do want to change one thing. We're essentially done. And then I'll show you the whole graph. So I want to turn on scroll equals true. I think that works. So that just turns us into a scrolling graph. Yeah. Okay. And there's my bearing plot. Now, I'm not too happy with that, right? Because it didn't really change that much. Let's just change this. Let's make it look better by going from negative 100 to 100 instead. So change this. Just zooms on that. Okay. Let's just change the velocity of the boat so that it is going let's go faster. So 8 and negative 70. So it's more towards the boat. I want to get a more dramatic. There we go. Okay, now here's something weird happened. I'm glad I did that. It crossed the path, right? And so since it crossed the path, it switched it. When I took the, this gives it a bearing, I'm not sure the best way to handle this because I want, if the bearing, well, I think I'm going to have to work on that. That's because I'm going to give you some homework, okay? See if you can fix this, because this should keep going down this way. What happens when it crosses the bow of the thing? It's not working then. And then what if the boat turns towards the submarine? What would that look like? See if you can build that. And then what would happen if you have multiple contacts? But I just want to give you an introduction to these bearing graphs, bearing rate graph, and show you how you can make them in VPython, GlowScript VPython. So there you go. Hope that makes sense. Play with the code, do the homework, watch Smarter every day, and I'll talk to you later.